So our first example for our Notes 5.4 modeling and optimization are found in the packet. Make sure you read these steps. They're just good guidelines to follow when you're solving optimization problems. Now let's talk about example 1. It says find two numbers whose sum is 20 and whose product is as large as possible. I like to start by underlining what I'm trying to maximize. I want to maximize the product of two numbers. That is, the two numbers multiplied together. That's my goal by the end of this example. Now to model this, I'm going to think about what are my two numbers. Well, I could call one of the numbers x. It's an unknown. To figure out what to call the other number, I'm going to look at this fact here. The two numbers have a sum of 20. So x plus some other number, that's a mystery, has to equal 20. So this other number is really a value of 20 minus whatever x is. So my two numbers are x and 20 minus x. Now that I've defined my variables, I'm going to write down a product equation that models the product of these two numbers. The product of these two numbers are x times, and then in parentheses, 20 minus x. This is what I want to maximize, or rather, find the maximum of this function. So to do that, I'm going to distribute the x through, making it easier for me to take the derivative here. Now, why would I want to take the derivative of my product equation? Because that way I can find my critical points, use the first derivative table to figure out which point is going to be my maximum. Taking the derivative, I see I get 20 minus 2x. Now in this case, my critical points are going to come only from where the derivative is equal to 0. And in this case, when you solve this, you get x equals 10. Now you can't just assume because you get only one critical point that this is definitely going to be your maximum. You have to show through a table and some words that this is a maximum. So now I'm going to make my table. And I'm going to use p prime here just in the context of the problem. Now I need to think about my endpoints and my restrictions on these two numbers. The problem didn't tell me that the numbers had to be positive, so I can actually have any two numbers added together. So I'm going to start from negative infinity and go up to 10, my critical point, and then go from 10 to infinity. Now I'm going to pick points to test on each interval. This interval I'd probably pick 0. It's the easiest number to check. Plug in 0, you get 20 minus 2 times 0, which is positive. And on this interval I could choose, for example, 15. 20 minus 2 times 15, which is 20 minus 30, would give me a negative value. So this helps justify that when x is 10, this is the maximum product. I need to first write the two numbers. Are 10 and 10. If I put 10 back in here, 20 minus 10 is still 10. And I need to justify with why this is a maximum, since p prime is greater than 0, positive, on the interval to the left of 10, and p prime is less than 0 on the interval to the right of 10. Making p of 10 a maximum.